Today what we're going to do is we're going to solve systems like we've always done, but instead of having two systems with two variables, we're going to have three systems with three variables. Now normally when we solved a system of equations, right, it was a line and a line, they intersected, we found the point, right? What was another way we could solve a system? Graphing, what's another method?
Plotting.
No. Elimination and substitution. Okay. When we're doing the 3 dimensions, you're not going to do graphing because you'd have to draw 3 planes on a 2-dimensional space and it would be too hard for you to see. But if you look here, you can see what one would look like if you were to graph it. There's a chance that you could get a no solution where you have 3 planes that never intersect. Anyone have a guess or from geometry remember what those would be called? Planes that don't intersect? Parallel planes. Okay, not really if you don't want to, but that would be an example of a no solution. They don't intersect. This is also an example of a no solution. So even though the yellow and the blue intersect, the blue and the green and the yellow, all 3 of them don't intersect at one time. This is the one most often we're going to get on our answers today. We're going to have one solution. So we have the 3 planes intersecting, and it might be hard for you to see where all 3 of them, but they all actually 3 intersect at one point in the middle. Okay. This point will be an ordered triple, x, y, z. Here is an example where you would have infinitely many solutions. So you can see that all 3 of these intersect at all of these points. And technically, remember, planes go on forever, so that would be a line where they all intersect. So technically, you get infinitely many. But I would say 99% of the time, we're going to be getting one solution to these. Now, you'll notice we're going to solve by elimination and substitution. Today we're going to focus on elimination because all of ours will be in standard form, and that's the easiest way to do it. Basically what you're going to do is you're going to do elimination 2 times. We've normally only had to do it once. We're going to do it 2 times. And there's steps typed out to solve. So you are going to break the system of equations into 2 sets of 2 equations and eliminate a variable. You'll get 2 other equations. You'll then use elimination again. So it's 2 process steps of elimination. Now, I like to number them 1, 2, and 3. So that when I'm talking about an equation, I can say equation 1 instead of reading out what it is. Just kind of shortens the work. Now, when we're looking at these, you do want to identify what variable you'd like to eliminate first. Which one looks like it would be the easiest to eliminate first? Z. Why? The coefficients are all 2 or -2, right? So we won't have to multiply by anything. Now, if you wanted to, you could multiply, by something and get these to match, and you can do that. It's just longer. So I'm going to try and eliminate the z's. Now, we're going to split it up into sets of 2. So usually it's nice to have a positive and a negative, right? And then we can add them. So let's go ahead and break off. We'll have equation 1 and 3 as one of our pairs. And then I'll also have equation 2 and 3 so that I have a positive and a negative. Unfortunately, you're not allowed to add all 3 together because it would not eliminate a variable. If you add all of these together, you would get 2 plus 2 is 4, 4 minus 2 is 2. Wouldn't get you to 0z. So that's why you're going to do sets of 2 at a time. Okay? So right now, let's just go ahead and copy those over here. So equation 1 is negative 5x plus 3y plus 2z. Was 11. And if you can do this without recopying them, you don't have to, but I just think for the first notes example, it would be good to do it. And I'll also copy the other ones. And be careful, because if you mix the negative right here when you copy it, then the rest of the problem is going to be wrong. So, take care. All right, once we have them copied, we're going to solve each one by adding the 2 equations. Okay, so negative 5x plus 4x is a negative 1x. 3 plus a negative 7 is a negative 4y. And 2 plus a negative 2 successfully eliminates the z and gets me a 0, so I won't write it. Next we'll subtract these to get negative 18. 29 minus 11, and we'll keep our sign to be negative. Do the same thing with the other pair of equations. 12x, negative 12y, 2 plus a negative 2 successfully goes to 0. And then our last one would be negative 84. Okay, so we have successfully eliminated the z variable. We still have to eliminate now the x or the y. So we're going to take these two equations, put them together, and eliminate either the x or the y. So I'm just going to stack them on top of each other. Now, unfortunately, we don't have matching coefficients, right? So we need to multiply one of the equations by a number to get it to match. I think I would just multiply this by a 12, but you could also multiply this by a 3. A negative 3 probably would be best. It doesn't matter which one you do. I think on my, just so I have. Now you want to make sure you multiply all of them by that number. So we'll get negative 12x minus 48y, and that'll get me negative 216. And multiply. Again, if you did the y variable, you're going to get different numbers. Your answers are still going to come out the same. Now we add downward. So negative 12 plus 12 is 0. Negative 48 plus negative 12 will get me a negative 60y. And adding these, we're going to get a negative 300. Divide by negative 60. And we'll get y is 5. Now that's only 1/3 of the answer. That's the hardest part to get though. Okay, now you just have to plug back in. Because our final answer is going to be in the form x, y, z. So we have one of the three answers. Now, it doesn't matter technically where you plug it in, but it has to be to one of the two equations that only has two variables to start. If you plug this into one of these, you won't have enough information to solve. Okay, so you want to take the y equals 5 and plug it into one of the two from the first step. Okay, so I usually do this one. So negative 1x minus 4 times 5 equals negative 18. Add 20 to both sides. Make sure you do divide by a negative 1, and we will get x is negative 2. Now we have 2/3 of the answer. How do you think I find the last variable, z? Linz? Good. Plug both of those numbers into one of the originals. Doesn't matter which original because they should all get you the same answer. So I'm going to come up here. We'd have negative 5 times negative 2 plus 3 times 5 plus 2z equals 11. Follow your order of operations to multiply first. Add those together to get 25. Subtract. And divide. Take all three answers, then throw them into an ordered triple. So my final answer should be negative 2, comma 5, comma negative 7. Now, is this hard? Not really, actually. It's just very long, right? It's something you know how to do. You know how to solve by elimination. It just is a lot of steps. And if you were to mess up a negative, let's say here or here, just somewhere, everything else will be wrong. Okay? So tonight on the homework, I'm going to give you all the answers. They're typed up on the homework, so you don't even have to go to the classroom to look at them. And you can just flip to the back and make sure you're getting the right answer before you plug it back in. Okay, just for the first night. Now on your quiz, you won't get that opportunity. But it will help you to kind of, like, if you make a mistake early, catch it before you plug in all the wrong numbers.
Is there either way you can
Okay. If you want to shorten the work, you can do this without having to recopy everything if you look carefully. So let's number our equations. We only have to do this one and another one. And then you guys can start your homework. We're going to skip the closure today. But label these equation 1, 2, and 3 just to help keep you organized. What variable do you think we should eliminate? Why? Okay. Now we want to pick two pairs of equations that we would add together. Which pairs do you think we should pick? Jacob? 1 and 2 and 1 and 3. Okay? And that's because we'll have a positive and a negative and a positive and a negative. Now, before you start copying them over, if you think you can do it without recopying them, you don't have to. So watch what I mean. We're going to add equations 1 and 2. So 2x plus 3x is 5x. Y plus a negative y would be 0. Negative 1 plus 2 is just plus 1z. 5 plus a negative 1 is 5 minus 1, which is 4. So if you don't think you need to recopy them, I'm not going to require it. You just might want to so you don't make a mistake. Now the next one we will have to, but this one no. Now we're going to add 1 and we're going to add 3. Okay, so kind of ignore or hide that middle one. So 2x plus 1x is 3x. Y plus a negative y is 0. Bless you. Now be careful, this is negative 1 plus a negative 1, which would be a negative 2z. And then 5 plus 0 is 5. So that did shorten the time we had to rewrite everything, right? Now we're going to take these two, put them together, and create a system. Now again, to save yourself a little time if you want, you could multiply this by something or this by something to get the coefficients to match, right? Bless you. So 5 and 3, I'd have to multiply both of them by something. But I could make this 1 become a negative 2, right? So I could multiply this whole equation by a negative 2, which will get me negative 10x. Oh, not a negative 2, I'm sorry, a positive 2. We want them to have different signs. So 10x plus 2z equals 14. Just copy this one down below. I don't know where I got 14. This is 8. Not 4. 5 times 2 plus 4. I don't know. All right, then we add these down. We'll get 13x. These do go to 0. Equals 13. X is 1. Okay, so that might make it feel like it's less work, right? Because we didn't write as much. We feel a little, I don't know. Plug x back into either this equation or this equation, one of the two that has only two variables. We'll get z equals a negative 1. Now take both of these and plug it into one of the originals. Again, does not matter which one. Now be careful, this is minus z, so that's minus a negative 1, which we know will turn to a positive, right? So we'll have 2 plus y plus 1 equals 5. Y plus 3 equals 5. Y is 2. Make sure you don't do all that work and then put them in the wrong order. X, then y, then z. 1, 2, negative 1. Again, some of you will be doing the homework and you'll get all of them wrong. And it literally is not because you don't know what you're doing, it's because somewhere you messed up a sign, one symbol, one negative, and then the rest of the problem's wrong. So if that happens, come in homeroom tomorrow and I can usually find your mistake. It might take me a minute or so. But it's very, very small, so just take your time. Now the last one we're going to do together is number 3. And then the closure, I'll give you the answer in case you want to try it, but I'm going to let you start on the homework in class so you can ask questions. Now, this one is harder. Why? What's different about this one than the last one? Maddie? Good. On all the other ones, like we had matching coefficients to start with. In this case, none of these are matching to eliminate. So that means we're going to have to multiply by a number to get them to match. Now, here's the thing. You don't have to make all three of them be the same. You can if you want, but you do not have to. You can make pairs of them be the same. Because remember, we're just going to put two of them together and two of them together. So instead of making like all these be 24, which you can do, your numbers are just going to get real big. Let's number these 1, 2, and 3. You only need the pairs to match. So for example, if I choose equation 1 and 2, I can easily make this match this, right? So I'm going to choose equations 1 and 2, but I'm going to take equation 1 and I'm going to multiply it by 3. That way I'll get 3x, etc. Okay? My other pair that I'll pick, and there's many options, this just happens to be the easiest one. 1 and 3 I can pick. I can make the 1 become an 8 really easily just by multiplying by 8. So I'll choose equation 1 and equation 3, but equation 1 has to get multiplied by 3. Or excuse me, 8. Alright, so let's first of all multiply this one by 3 first. Now, this one is the one where a lot of students will forget to multiply that last number by 3 or 8. Make sure you have everything being multiplied. So we will get 3x plus 6y plus 15z equals 3. Equation 2 does not get modified, it just gets copied over here. For the second pair, we're going to multiply the top equation. I'm going to change this 3 to an 8. Multiply everything by 8. So we'll get 8x plus 16y plus 40z is 8. Then I'll copy down this one. Yeah, you might want a calculator for this one. Maybe not at the beginning, but especially when we have to find a common coefficient for the next terms. All right, so we're going to add down. 3 plus a negative 3 is 0. 6 plus 3 is 9. 15 plus 7 will get me 22z. 3 plus 4 is 7. And you'll see I put a slash through my z so it doesn't look too. Do the same thing over here. 16 plus 5 is 21y plus 52z equals 19. I'll wait until everyone gets caught up. Now the problem here is that I can't make 9 become 21 easily, and I can't make 22 become 52 easily. So I'm probably going to have to multiply both of them by a number to get them to match. Suggestions? Josh? Make it 63. Okay. So the least common multiple between 9 and 21 is 63. A lot of you are sitting there like, what? Where did he come up with that? I wouldn't think that. That's okay. You don't have to. If you don't realize that the least common multiple is 63, you can just multiply this one by a negative 21 and multiply this one by 9. You don't have to find the least common multiple. It's just going to make your numbers smaller. Okay, so for those of you that aren't following the track, what Josh said, you can do this. If you are following what Josh said, you would multiply this by a negative 7 and multiply this one by a 3. It doesn't matter. You just have to get them to match. Okay, on my paper I did the 21 and 9 on this paper, and I did the 63. Which one do you want on the board? The 63? Okay. So go ahead and distribute all of that. And we are going to get some big numbers here. You could have done the negative on the other. It doesn't matter where the negative goes. Then distribute your 3 over there. and then we'll add downward. So we'll get 2z equals 8. Not on this one. Should get z is 4. Plug 4 back into one of the two equations that we found before. Should get y is -9. And then I'd like you guys to take these two numbers and plug it back into one of the originals, find out what x is. Alright, so plug these into the original. So that would be x plus one of the originals. It doesn't matter which one. Well, it should still work if you plug it into one of these. Now, the mistake some students make is that they plug the number in for the wrong variable. What can happen? So this would be -1, -9, 4. Okay, the closure, just in case anyone did it or interested or wants an extra practice problem, which you'll get plenty before Friday, but the answer is 2, -1, +1. And just remember, on your quiz Friday, if you have time, you can take this and plug it back into all of them and make sure that it equals the number. Like, you can check your work by plugging in the x, the y, and the z and making sure all three of them come out to be -7, 7, and 8. On the back of the homework,